let's take these dry statistics and turn them to life with some patient information. So we're going to move forward with our case that we've been working on. So Mrs. Triglione made her way back to the emergency room and was seen by the team there, and the intern calls you from the emergency department and says the following. Mrs. Triglione is here. I know you're concerned about a pulmonary embolism, but she is allergic to contrast. We did recall that. So she couldn't get the conventional test, and instead we sent her for a VQ scan, a ventilation perfusion scan, and we'll let you know when the results are back. So being the good diagnostician you are, you realize that you're going to need to figure out how to interpret a positive or negative test before the results are back. And so you quickly consult the internet and find an article that says that the sensitivity and specificity of VQ scanning are about 77% sensitivity and 97% specificity. So quiz 4.5, I'd like you to make a commitment. What are you going to do if the test comes back positive? And remember, as you think about that, recall the sensitivity of the test, which is 77%, and the specificity of the test, which was 97%. And you thought that Mrs. Triglione had a very high likelihood of pulmonary embolus based on her clinical history. So your options are you could start treatment for a pulmonary embolism if the test comes back, or that you might obtain additional tests because you wouldn't be certain that she had had a pulmonary embolism. So I'm not going to give you an answer. This is just a quiz that forces you to make a commitment, as all of us have to do in the practicing world. And, of course, what are you going to do if the test comes back negative? Will you send her home with reassurance, having ruled out a pulmonary embolus? Will you try and obtain additional tests to further clarify whether or not she has a pulmonary embolus, or will you start treatment? Again, I'm not going to give you the answer. I'm asking that you make your own personal commitment based on your understanding of the work we've begun today. Good. So let's go back to our 2x2 contingency table and put in some real numbers looking at Mrs. Triglione's case. So as we said, we thought her pretest probability of disease was in tier 1, either likely or very likely, and for the purposes of this exercise, I've chosen a pretest probability of about 80%. And what we want to figure out is what will happen if her test comes back positive or if her test comes back negative. So we know the test characteristics of a VQ scan, sensitivity of 77% and specificity of 97%. So let's remember how we use that. In order to complete a table like this, you assume a population of 1,000 patients. It's just a convenient number that's easy to do the math with. You could choose 100, you could choose 10,000, and you could choose 85, but we're going to use 1,000. And then to fill in the test, first we use our pretest probability of 80% to fill in this quadrant here, the quadrant E, which is all people within the total population who actually have the disease. And we're estimating that about 80% of people who look like Mrs. Triglione does in this clinical situation will turn out to have this disease. And so of that 1,000, that's 800, which means that in the population of people who look just like Mrs. Triglione, only 200 will be free of disease, and that's this column. So got it? Good. So then we use our sensitivity and specificity combined with that prevalence statistics to fill in our different quadrants. So we multiply 800 times sensitivity to get quadrant A. And that's 616. You can take my word for it. 77% times 800 is 616. Of course, that math makes sense, right? Because sensitivity is A over A plus C. And A plus C is equal to 800. So 0.97 times 800 is equal to A. That, of course, means that C is 184. So that's how our sensitivity statistic helps us. And specificity, remember, is D over D plus B. So it's this over this. So you multiply 200 times the specificity of 97% to give you 194 in quadrant D. Now, why bother to do all of this? Well, we need to fill in these quadrants in order to figure out our post-test probability of disease and our post-test probability of health. So, prevalence of 80%, sensitivity of 77% gives us quadrant A 16, and a specificity of 97% gives us a quadrant B of 6. And so our post-test probability of disease is 616 over 622, or 99%. On the other hand, our post-test probability of health is 194, which we arrived at by multiplying 200, that's the percent of people we think don't have disease in this population, times specificity. And our post-test probability of health would be 194 over 194 plus 184. D divided by D plus C. And that is 51%. Got it? Good. So let's apply that to our likelihood ruler over here and see what that looks like. This is the same table exactly with the same numbers as the last slide. And we're going to say we started with a pretest probability around 80%. And if our test turned back positive, then how would that affect our post-test probability? Well, we'd say we want to know what's the post-test probability or positive predictive value of the test. It has gone up from 80% to 99%. So this turned out to be a helpful test in moving our pretest probability up from likely to very likely. So we feel even more confident that Ms. Triglione has the disease if her test came back positive. So that answers your question, perhaps, of if her test comes back positive, what are you going to do? And I hope you answered, I'm going to treat her because her pretest probability of disease was already likely and we moved it up to the almost certain. But what if her test comes back negative? So then we want to look and see, well, not what the post-test probability of health is or negative predictive value, but we want to know on this likelihood ruler is how likely is it that she still has a pulmonary embolus if her test is negative. The negative predictive value tells us how likely is it that she's truly healthy, but it's the false positive rate or 1 minus negative predictive value that tells us how possible is it that she still has the disease even in the setting of a negative test. And so, that is indicated right here. So 1 minus negative predictive value is 1 minus 51, which is, of course, equal to 49. So if she, in fact, has a negative test, starting with a pretest probability that's very likely, we didn't exclude the possibility of pulmonary embolus. We just moved it from likely to uncertain. And with a serious disease like pulmonary embolus, that doesn't feel good enough for us to feel confident to tell her that she's free of disease. It just moved us a little bit in that direction. So, the intern who hasn't been taking this course and doesn't have your sophisticated understanding of these tests calls back and says, good news. The ventilation perfusion scan is low probability. That means she doesn't have a pulmonary embolus, and we're going to send her home with some analgesics and have her follow up with you in the morning. So, quiz 4.7, how should you respond to that intern? Number 1, good job. Tell her to call the office first thing in the morning. So, accepting the intern's conclusion that she didn't have a pulmonary embolus and that you can follow her up tomorrow and figure out what else might be going on. Number 2, good job. Tell her to follow up next week as scheduled. You accepted the intern's conclusion that she didn't have a pulmonary embolus and don't think there's anything that needs to follow up sooner than that. Or number 3, thanks for the update. Let's review her case and rethink your conclusion. First, let's start her on treatment while we get another test. So the answer, of course, is number 3, because as we showed you in this probability ruler, we had a very high likelihood of pretest probability of pulmonary embolus in Ms. Triglione. The negative test with this level of sensitivity, which is pretty poor, a sensitivity of 77 is pretty poor, didn't allow us to rule out the disease. It actually just allowed us to decrease the likelihood from likely to truly uncertain. Good. I hope you got the right answer for that. So what this has shown us in dealing with a test that is very specific, specificity of 97%, is that when the test that's very specific is positive, it can help rule in a tier 1 diagnosis, right? Remember, specific test when positive rules in the disease, and we had a test with a very high specificity, 97%, and a positive test moved us all the way up to about 99% for the patient that we were testing. But importantly, in a patient with a high pretest probability like Mrs. Triglione had, tier 1 is a likely or a very likely diagnosis, a negative test doesn't exclude the disease. This is really important because a negative test is as likely to be a false negative as it was to be a true negative. So, what if we applied the VQ scan to Mrs. Garcia, who had a pretest probability of less than 10% by our Wells criteria? Remember, we had estimated that she was a true tier 3, and by Wells criteria, she turned out to have a very low probability of pulmonary embolus. Same sensitivity and specificity, not very sensitive, highly specific. Again, we populated our 2x2 contingency table. This time, we used the same population of 1,000, but we multiplied 1,000 by a probability of 10% to fill in quadrant E as 100. So do you see how this, again, this changed our quadrant E because the pretest probability was so much lower than for Mrs. Triglione. And then we use that figure of 100 people in a population looking like Mrs. Garcia who might have a pulmonary embolus, multiplied it by 77% sensitivity to get quadrant A, and then by extension quadrant C. And in this situation, many, many more people have a pretest probability of being healthy. And so 900 is our F quadrant. And we multiply that 900 by the specificity to calculate our D quadrant, 900 times 97%, and then by extension our B quadrant. And on our likelihood ruler over here, we have indicated that Mrs. Garcia's pretest probability is down here near the basement, around 10%. Good. So remember, the reason we populate this is to calculate our post-test probabilities. And in this situation, our post-test probability of disease, or positive predictive value, is A, 77, over A plus B, 77 plus 27. And that comes out to 74%. And our post-test probability of health is D, 873, over 873 plus 23, all people who test negative for the disease, or 97%. So how does that affect our post-test probabilities ruler? Again, the same slide with the same calculations, just a little bit more space over here, pretest probability indicated here. If the test is positive, that moves our pretest probability from 10% to 74%. So we've moved from very unlikely to likely. If Mrs. Garcia had a positive test, we'd be a little bit worried. And the reason this was so powerful a move is because the specificity was so high. Remember, a specific test, when positive, rules in the disease. So didn't quite rule it in, but it got us pretty high compared to where we started, right? But look what happens when we get a negative test. And we want to ask the question, what's the likelihood that Mrs. Garcia still has a pulmonary embolus, even if she tests positive for the disease? Remember, what we want is that statistic is 1 minus the negative predictive value. We're looking for the false negative rate. And so 1 minus negative predictive value is 3% here. So we've really pretty much eliminated this disease in this patient with a negative test. Now, You're going to ask me, well, isn't it the SNOUT test that rule out disease? And the answer is yes, but in fact, we started with a really low pretest probability, so any negative test is going to move you down to even lower. It didn't give us that much additional information. We went from 10 to 3%. But a positive test in this environment would have been hugely interesting, right? Because it went from 10% all the way up to 74%. And then we'd have to decide what to do with that information. So what I want you to see here, though, is how these tests with the same sensitivity and specificity perform very differently depending on the pretest probability of disease. Whether it's very high, like Mrs. Triglione, or very low, like Mrs. Garcia. You have to think ahead about what a test result is going to mean in the different populations in which you're considering the diseases. Another way to say this is when a disease or diagnosis is unlikely, a positive test, even if the specificity is high, doesn't confirm the diagnosis, but it certainly increases the likelihood from unlikely to certain. And when a diagnosis is unlikely, a negative test further decreases the likelihood.